This pencast is about rational equations. Rational equations have variables in the denominator, so we must carefully consider the domain of the problem even before solving it. For example, if we take 4 over 3y minus 3 over y equals 10/3. Notice how we have y in the denominator, and so we can note that y can't equal 0. So the domain of this problem is that we can substitute or solve for all values of y except for y can't be 0. The LCD of this problem is 3y. We're going to multiply all terms, both sides, by 3y to clear out the fractions. And that will turn it into a much nicer looking problem. After we cancel, we have a 4 from the first term. The y's cancel. 3 times 3 is 9. 4 minus 9 equals 10y. Right now what we're looking at is negative 5 equaling 10y. If we divide by 10, we get y equals negative 1/2. Before we box this in as our answer, we want to make sure that we're allowed to have y equal to 1/2, negative, and it's okay because y can't be 0. Our next example will be a little more complicated. It'll be 550 over y minus 50 over y minus 2 equals 4 over y. Now, we can't have y equal to 0 and y can't be equal to 2. So we want to note that y can't be equal to 0 and y can't equal positive 2. Otherwise, some of the terms are undefined. Now, the LCD of this problem is y times y minus 2. So we want to multiply all terms by y times y minus 2 to clear the fractions out. This is the most efficient method for solving a rational. I don't know why I wrote 50 y times y minus 2 times the right-hand side of the equation. Again, here on the first term, the y will cancel, but we're still left with a 50 times a y minus 2. From the second term, we would still have a y. The y minus 2's would cancel, giving us a y times a 50. Of course, that we'll write it the other way. Equals y minus 2 times 4. So if we distribute, we have 50y minus 100 minus another 50y equals 4y minus 8. The 50y's cancel. We have negative 100 equaling 4y minus 8. Adding 8 to both sides, we get negative 92 equals 4y. And if you divide by 4, 4 goes into 9 2 times, and then you get negative 23, which is fine because y can't be 0 or 2. And the answer to this problem is that y equals negative 23. Now for a much longer example, we'll do 6 over x squared minus 4x plus 3 minus 1 over x minus 3 equals 1 over 4x minus 4. First thing we want to consider is the domain. So to find that, we want to know where the denominator would be 0. Let's factor. We want two numbers, sum a product of 3 and a sum of negative 4. That would be a negative 3 and a negative 1. So if we're identifying the domain here, we can note that x cannot equal 3 because x minus 3 equals 0 and x is 3. X also cannot equal 1. And now 3 we've already written down, and 1 we've already written down. That's when 4 times x minus 1 equals 0 also. So our domain is that we could have x equal to any number but 1 or 3. Now, we factored each denominator, and so our LCD this time is x minus 3. We only need one of those. We need 1x minus 1, but we also need a factor of 4. If we multiply all terms, both sides, by this, we will clear out the fractions and once again make this look a lot nicer. We get 6 over. I'm going to write it in the factored form here, just so you can see the cancellation a little easier, more easily. So we're just writing it out to show our steps. I'm running low on paper here, not enough room. 1 over 4 times the quantity x minus 1. Alright, now this is the fun part. We can just cancel anything that cancels. Now notice how the new form of this equation is 24. It looks a lot nicer. I cancel the x minus 3s. You have minus 4 times the quantity x minus 1. And on the right side, the 4 and the x minus 1 cancel, leaving us with x minus 3 times 1. I'm just writing that to make sure you remember to multiply by the numerator there. So now what we have is 24 minus 4x plus 4 equals 0, equal to x minus 3. 24 plus 4 is 28, minus 4x equals x minus 3. We want to get x's on one side. I'm going to add 4x to both sides, giving me 5x minus 3. Then we add 3 to both sides. We get 31 equals 5x, and x equals 31 over 5, and x can't be 1 or 3, so we're okay.